Python's pip installer just got beaten. In some real-world tests, UV installs JupyterLab 8 times faster. In others, 100 times. Your CI pipeline spends 4 minutes and 40 seconds waiting for pip to install PyTorch and HuggingFace transformers. With UV and 0 cache, that drops to 38 seconds. With UV's cache warmed up, 8 seconds. UV is Astral's Rust-based package installer. It shipped in February 2024, 9 months after PyPI enabled PEP 658. It's already replacing pip in production. Thomson Reuters cut CI builds from over 5 minutes to under 1.5. Same packages, same versions, same log file. That's a 3.5 minute saving on every commit. But speed comes with trade-offs. UV follows specs strictly. Pip has 20 years of lenient edge case handling baked in. Legacy packages that just work with pip can break with UV, and it gets worse. So let's take it apart. 5 architectural changes make UV fast. One of them couldn't have existed before May 2023. Another eliminates 99% of the work. Change 1. Pip resolves dependencies sequentially. It figures out what package A needs, fetches that metadata, then what package B needs, checks for conflicts, backtracks if it hits one. UV fetches metadata for everything in parallel, then runs a SAT solver called pubgrub to find compatible versions all at once. Pubgrub is a conflict-driven clause, learning algorithm originally from Dart's Pub Package Manager. It's the same technique used in formal verification. When pubgrub discovers 2 packages can't coexist, it records the incompatibility as a clause. Any future partial solution containing both is ruled out instantly by unit propagation. It learns from conflicts and never repeats the same mistake. Change 2. Before 2023, resolvers had to download entire wheels just to read their dependencies. The playwright wheel is 40 megabytes. The metadata file inside is a few kilobytes. You download 40 megabytes to read 4 kilobytes. PEP 658 fixed this. Approved in 2022. Live on PyPI in May 2023. It put package metadata directly in the simple repository API. UV launched 9 months later in February 2024. Now, the simple API anchor tag carries a data dist info metadata attribute with a SHA-256 hash. UV fetches that few kilobyte metadata file directly from PyPI without touching the wheel at all. If PEP 658 metadata isn't available, UV falls back to HTTP range requests. First, a head request gets the file size. Then it fetches the last 128 kilobytes containing the zip central directory. It parses that to find the metadata file offset. A 40 megabyte wheel becomes 2 small range requests totaling maybe 130 kilobytes. That's skipping 99.7% of the download. For a package with 73 platform-specific wheels, UV fetches metadata from any one wheel and reuses it for all platforms. That turns 73 requests into 1. It's a risky assumption, but it works for all major packages in practice. Change 3. Pip copies packages into every virtual environment. You create 10 venvs with NumPy 2.0. You get 10 copies of NumPy on disk. Same file, replicated 10 times. UV keeps 1 copy globally at ~.cache/uv/wheels, then hardlinks it into each venv. On macOS, it uses reflinking, on Linux hardlinking. Same file, same inode, same disk blocks. Install the same package into 10 venvs, it takes the same disk space as 1. The cache directory structure is simple. All extracted wheel contents live at ~.cache/uv/wheels. Built wheels from source distributions go into built wheels. Downloaded archives into archive v0. Git repositories into git v0. Change. 4. Pip stores package metadata as JSON. Python parses it on every install, converting text strings into data structures. Every field is decoded, every string allocated, every object constructed. Whereas UV stores metadata in .rkyv files, a 0-copy binary format. The bytes on disk are laid out exactly as they appear in memory. No parsing, no string conversion, no allocations. Access complexity is O of 1. Over 90% of package versions fit in a single 64-bit integer. Comparison and hashing are fast machine operations. Change 5. Pip downloads packages one at a time. It waits for package A to finish, then starts package B, then package C. Serial downloads, serial extraction, serial installation. UV spawns dozens of parallel downloads using Rust's Tokyo async runtime. Rayon parallelizes extraction across all available CPU cores. Network and disk work overlap. While package A is downloading, B is extracting, C is installing. Real-world numbers. On GitHub Actions with a PyTorch stack, pip with no cache takes 4 minutes 40 seconds. UV with no cache takes 38 seconds. With UV's cache action, 8 seconds. That's a 35 times speed up. Now the honest part. Speed comes from elimination. Every code path you don't have is a code path you don't wait for. UV is fast because it doesn't do work pip does. No .egg support. Eggs were the pre-wheel binary format, obsolete for over a decade. Pip still handles them. UV doesn't even try. No pip.conf. No bytecode compilation by default. No legacy setup.py edge cases. GitHub issue 12,772. User reports UV 0.6 fails on packages that pip installs fine. Rolling back to UV 0.5, 31 fixes it. The package wasn't broken. UV was stricter. UV rejects packages with invalid version specifiers. Pip installs them anyway. UV rejects HTML indexes with malformed URL fragments per pp503. Pip ignores the fragments and continues. Strict spec compliance means some edge cases break. Universal resolution is another edge. UV generates cross-platform lock files, so it needs metadata for all platforms even if you're only on Linux. If a Windows-only package has no wheel and no static metadata in the source distribution, UV must build it on Linux just to read its dependencies. Pip never had to do this. It only resolves for your current platform. UV resolves for all platforms at once to generate a universal lock file. That's a feature, but it means more builds. PyTorch-style local versions are another trap. If you specify Torch 2.0 plus CU118 as a direct dependency, UV accepts it for transitive dependencies. But transitive local versions don't get this treatment. They must be pinned explicitly. You can't let the resolver discover them. Cache fragmentation bites in CI. Each pull request stores its own copy of .venv and ~.cache/uv, even with identical lock files. Same dependencies, different PRs, different caches. GitHub Actions storage fills up faster. The fix is a global cache keyed to the main branch, shared across all PRs. This workflow cuts repeated installs to under 10 seconds. The Astrologic setup UV action installs UV, adds it to path, and provides a cache for installed packages. Build failures are usually not UV bugs. You can confirm by attempting to reproduce with pip. Most of the time, it's a system dependency missing, a compiler flag wrong, or a platform constraint violated. If pip fails too, it's not UV. Quick recap. PubGrub resolves in parallel with conflict learning. PEP 658 and HTTP range requests skip wheel downloads. Global cache with hard links eliminates disk copies. Zero copy RKYV deserialization skips parsing. Rust async parallelizes downloads. Know the trade-offs. 10 to 100 times faster install speed, but stricter spec compliance. Hard link deduplication saves disk space, but legacy.egg support is gone. CI builds drop from minutes to seconds, but you need to redesign cache keys. Test your dependencies before you migrate. One more thing, UV couldn't have existed before May 2023. The speed isn't just Rust, it's that PyPI finally had the infrastructure to support it. PEP 658 made UV possible. A tool like UV couldn't have shipped in 2020. The standards weren't there yet. Now go fix your CI pipeline. Your future self will thank you.